Welcome everyone. I'm Sanju Burkule. I'm your host, and today we have a session which is a direct experience of what we saw in these past few years. We were all excited about containerization, and we still are. What we witnessed is as we started scaling the applications that we were delivering, we saw some issues where we thought it would be easier to go the serverless route, and so we tried that option. And we had a couple of success stories to share on what are the key benefits which we saw while delivering these apps, while we were choosing the right components to move to serverless. So that's basically the focus of this session. It's going to be a quick session of 30 to maximum 40 minutes. So without further ado, let's get started. So Vijay and Punamit Nagarkar, GG is how we call him. So they're the co-founders of Applied AI Consulting. So let's get started right away. Vijay, would you like to take us through the flow?
Thank you, Sanju, and thank you everyone for joining in. I see a lot of familiar faces and good to see you all. So great. This should be close to 30 minutes to 45 minutes of discussion that we'll run through. A lot of learnings that we have seen during working with different products and customers. So I'll go through the expectation setting, what to expect from this webinar, what you can take away at the end of 35 minutes, 45 minutes that you will be spending here. Then Gigi would talk about a case study. So there'll be two case studies that we'll be discussing. Very interesting ones where we had the entire journey of that application modernization. We'll talk about that. In between, I'll just recap all the understanding that Gigi is talking about to make sure that we are assimilating that knowledge. And we'll keep enough time at the end to have questions and answers. And in between, if there's anything, you can always put in the chat. Otherwise, at the end, we'll have enough time to go through it. So with that, let me jump on. And before I even move to serverless, this was while I was putting together this deck, I chanced upon this beautiful, graph where it was talking about that, long back during Lebanese civil revolution, all the landlines were destroyed, and then a lot of people skipped landline and just moved to mobile. And those who are from India, they have seen this, right? That landline was always a premium commodity, and then when mobile came, thanks to Reliance, and then it just zoomed ahead. So we have seen a leapfrog of from landline to mobile phone in adoption. Are we seeing the same thing in world of serverless? Are we seeing that people are moving from blade to virtual machines and then skipping containers and moving to serverless? Now, let me talk about my experience working with so many customers till date. I am seeing customers adopting serverless in a lot of cases. We'll talk about a couple of case studies here in the discussion today. I was going through a report from Pathfinders where 75% of the organizations use or plan to use serverless technologies within the next 2 years. So we are seeing that customers are now adopting a serverless first approach. There was a lot of buzzword about mobile first approach. Now we are talking about serverless first approach. So am I seeing a jump? I am seeing, but I will talk more on this, that how am I seeing a jump in the case studies. To set the expectation about this session, we are assuming that you know what is serverless and possibly may have used in one or other scenarios. So we'll go through our experience of serverless implementation. We'll talk about the real life challenges we have faced and how did we circumvent it or manage it, and then some tools that we have used to achieve that. So this is not a session about theory on serverless. This is not a sales pitch. We are not going to talk about what is function as a service and how to do that. And I mean, there is no panacea for the challenges that we have. I mean, it's the hard way that we have learned. We are going to share our experience on that. With this, I'll move to the case study. But before that, at the end of, the takeaway that I think that we'll have is you'll be able to visualize your application, which is a candidate for modernization, and figure out what can be a candidate for serverless, what cannot be a candidate for serverless, which can be containerized, which cannot be. So even if you take this much out of this webinar, I think we'll be successful. So the case study that we are going to talk about, and I'll pass on the ball to Gigi, but the setting the context. So this solution, when we started talking about it, we deliberated, we rationalized the application, looked at it piecemeal to see which are the candidates which can become a good candidate for serverless, and how did we did that rationalization, what thought process we brought in. Gigi, over to you.
Hey, thanks a lot, Vijay. Good to see some familiar names and faces there, and thanks everyone who joined, thinking about getting some benefit out of it. And Vijay mentioned a very important point about some key takeaways that you will want to look at the end or toward the end of the slide. But let me try and walk through the first important story or experience that we went through when we picked up an application which we have developed over last maybe little more 4 to 5 years or 3 to 5 years out of a timeline, which is called as 7 Targets AI Sales Assistant. This is an application which is the primary users of the applications are sales and marketing team members, with the goal of improving or enhancing the productivity in the business, right? And in a nutshell, what does that do, right? In few points, it's about ability that the assistant has to send and receive emails. And while it is sending emails, do some intelligent follow-ups in terms of refining the time, in terms of changing the dates and times to be able to get more delivery, to be able to get more opens and all, right? That's one. And when it receives any response, then the assistant has the capability of reading the content, the context of the email, and classify the response into some of these different classes, right? And that's where the ML part plays in. Like if a lot of the times the response could be an out of office automated response. The assistant does have the capability of identifying what is the response, and if it is out of office, identifying till what date or time that person is out of office, and making a decision that if I am sending a follow-up before the person comes back, then let me go and change it, right? If the response is something like somebody is asking for, if that lead is asking for a profile, a business profile or a company profile, then assistant would be able to read that, understand that, and if the assistant has that information, then send it back within a matter of minutes. So those are the key functionalities of the assistant. There are much more, but let's stick to that. And then for sure, if there is more information within a response in terms of the phone numbers or titles or more, then pick that up, identify those entities, and enrich the leads within 7 Targets. So in a nutshell, that was the application built over a period of or rather maybe 4 or 5 years back, or thought beyond that, but at least built 4 or 5 years back. When it was built, it was a monolith that was built, right? The server side, the DB, the UI side, be it Angular, React, whatever else we use, were deployed on instance or instances, put in behind a load balancer as it grew. But pretty soon, as the number of users, number of customer increased, the primary functionality increased the performance problem because of the load increasing, right? The leads increased, the number of emails being sent or received increased, and got into performance problems, which led into problems of some unhappy customers, some churns there, and that's the business problem that landed us to think, or made us to think in terms of what can be done about it, and what is the path to take ahead. How do we solve the performance problem? How do we solve the cost problem because of the irregular usage? The load predictability was difficult, and so getting a right cost in terms of what would be the right cost and how do we reduce the cost was difficult, right? And if there are failures in production, how do we have a right amount of supportability to take care of those failures? So those problems made us think through in terms of what could be the solution. We sat together like we all do always, came up with a few options. So for sure, first one was rejected, but still it was important. point to discuss, that can we continue as is, throw in more people, throw in more infrastructure, throw in more tools, and can we continue as is, as is, to make sure that the customers are happy and they are getting what they're wanting. It would have possibly solved the performance problem, but the cost would have increased really high, right? So that's why it was a reject on day one when it was thought. Um, by this time, maybe a year and a half, maybe 2 years after starting, or after it being in production in that monolith world, we were already in the containerization discussions. So not that we were not thinking about, we were already into it. We were thinking, we were possibly even saying, okay, let's run it as is, as a container, and put it in there, and try and see if we get some benefits which were not going to be much different. But we were discussing those, right? I mean, at least divide or break up some of the services into some microservices, some services, if not microservices. But this problem of this business problem made us also think that, are there are there components, are there modules, are there services which we can move to serverless and get more benefits, and are there real benefits of it, right? So that's where we when we went on to whiteboards, one of the first important thing that very easily came out was that the UI code piece, which was running on an instance behind a web server, could very easily be moved to an S3 and a CDN based, where we don't have to worry about compute and those stuff, and we gain the performance of it. So that was very quickly done. Then, like I talked about the application, right? There's a lot of backend processing, background processing, in terms of sending follow-up emails at the right time, in terms of processing the responses received. So that became an important point for us to pick up, that hey, this is the background processing that is happening. If there is a small delay of a cold restart or something that happens in the application because of serverless, which came as an important point whenever we talked about can we move to serverless, right? The cold restart became an important problem for us to discuss. Will it add into the performance problem for us? Was one of the problems that came out um, upfront. Will it lead into monitoring and log consolidation problem, which are different than what we were having earlier, when we were not having such serverless or distributed sort of solution? But when we looked at the pros and cons, we felt that moving some of these background processing units or modules to serverless is going to give us the benefit of higher supportability and less cost, because of it being irregular load or surge in demand. Reducing surge in demand will help us scale without worrying about putting the right, or identifying and putting the right metrics for scaling the container based solution. And that's where, and if there are any failures, it was easy to be able to go and trigger the same event, to go and make sure that the processing completes without impacting the customer, right? So that's where the problem came up with, made us think, what do we do? And then serverless for at least some of the pieces that were event driven, that were background processing, that were some of those things, right, could be very easily moved. So we made the decision, we moved. Let me talk, how does it look like from an architecture or architectural slide perspective, or architectural deployment perspective, right? We do have a good amount of processing that is happening in serverless, like the one that I said, right? I mean, follow-ups or even response classifications and imports and exports and weekly notifications and all. Those are all happening in serverless mode using, I mean, we are an AWS shop. Doesn't mean, I'm talking generic sense serverless, but we are an AWS shop, and that's why I'm using AWS centric services there. Using serverless, using step functions, we were able to do it. Some more challenges that came up while we were doing it is, if the load that we are processing is high enough, is more, which cannot be completed in the time period that a particular Lambda function or a function which runs serverless, then what do we do, right? And that's where uh, we decided that okay, some of these functionalities can be processed in a parallel mode where the load can be divided. So divide and conquer was used, or breaking it into pieces and processing it for it to, which helped us not just processing it, but it helped us even completing it faster because we were dividing the work in multiple places. But some of the processes were not able to divide because the algorithms were such that it cannot be divided and data cannot be divided. And that's where we had to remain there. But going back to the benefits that we got from moving there, from making those decisions of moving some important services and modules to serverless, where uh, though we ended up using some pieces in containers or running in containers, and converting them to different services from monolith, uh, the skill challenges that we faced when moved to serverless were much less. Our engineering team were able to focus and get the learnings that are required for serverless in much faster way, like compared to understanding and learning and debugging and playing with containers, right? There were some challenges as well in terms of running or testing the uh, how do I test and how do I run the serverless component within my server when I'm building it. That challenge that challenge actually resulted into a better quality for us because people were not able to easily run it on their machines. So it was mandated that everything that you develop serverless has to have an 80 to 90% of coverage, and good amount of unit tests and integration tests were written. And then that's where the code was coming out in good or an acceptable quality from the hands of developer in the first run itself. So it helped us improve the developer productivity, if I look at it that way, right? Scalability and monitoring played an important, or was an important benefit that we derived out of this exercise, because when we thought of container scaling, we had to worry about refining the scaling triggers correctly. Out of the box, CPUs and memories are there, but when it comes to underlying metric that you have to have for your own internal metrics, depending on what you are processing and how are you processing and all, then you have to have your own triggers developed, and that's where we had to think and refine and build it, right? While when it was coming to serverless, it was easy because a finer function was easily able to scale uh, without we worrying about it. Yes, the out of the box configuration that came up with it had to be tweaked to make it work well for production uh, than what when we started, but it was an easy tweak compared to tweaking of the scaling triggers for containers for us. Cost reduction because of skill challenges, because of infrastructure, because of ease of understanding and focusing on the business logic versus looking at the infrastructure and bringing the container world and all, helped us maintain the cost or reduce the cost substantially. So, yeah, thanks, Vijay.
Good. So thank you, Gigi. I think this case study. Let me do something. Let me quickly recap what we went through just now, and then we'll move to another case study. So, in short, what we saw is that more than 15% teams are thinking of using serverless now, and more than 43% expect to do it in over time. And that's what we also did with 7 targets. We helped it move to serverless wherever it was suitable. The benefits that Gigi talked about and the screen that I'm sharing, the benefit that we see on the right hand side is coming out of a survey that was done by IDC. And we clearly see that the benefits are on the reduced TCO, total cost of ownership, both in terms of operational cost and developer cost. And I think we had a similar experience with 7 targets when we had close to 35% saving on the overall cost and also increasing developer efficiency. uh, Gigi talked about scalability benefit that we saw on 7 targets, and I see the same as number 2 item in the survey result that came from IDC, where scale with demand automatically. That's another benefit people have been seeing. And similarly, maintainability, supportability. Gigi touched upon all this. I'll not go through line by line, but one thing, another that interests me a lot is, unit testing. While testing is a challenge in serverless world, but unit testing is much easier. And this helps us, move our whole quality to the left side, right? Shift left approach. And this has been helping a lot in, delivering a quality product in the first go itself, and less reliance on, you know, heavy QA as a post thought. So with this, another thing that we, as a recap, I want to capture is how to decide a candidate for serverless. And important thing to note is containers and serverless are not competing technologies. They are not competing with each other. During application rationalization, we have to decide which part of the application of functionality is suitable for containers and which one is for serverless. This is super, super critical. And I mean, nothing different than what we did with 7 targets, where we brainstormed and decided that, hey, some of the pieces, let it be containers. And while other pieces like, background or async processes, that's the right candidate for serverless, because there is, you know, there is a variability in a demand, there is seasonality in a demand, and whenever they are required, they are used. Otherwise, you don't have to really pay for it. Then if there are event-based triggers for processing, that's the right candidate for serverless. If any failures in processing, and if we expect the support team to manage and try it easily, there's a serverless. So there have been situations in 7 targets where we have seen that sometimes an email sending is stuck or fails. It's just easy to go ahead and start that small function and not really boil the ocean. It, worry about entire container restart, application restart. So they are the good candidates, that are for serverless. But there are instances, for example, yes, late last week I was working for the electricity department of Australia. We were looking at, building an application for them. And what came with, there are some complex running applications, which cannot, which will take a lot of time to get executed. And in that case, we decided to go for what is called fat Lambda, where there'll be Lambdas which will trigger these containers. So that's a good marriage, right? Going hybrid. We are having serverless, also we are having, containers, and Lambdas are calling containers as and when needed. So that's what we call fat Lambda. So that's where we have to choose what is the right. Lot many times Lambda, the serverlesses will work, but there may be instances where we have to spawn one or other container and then use it for effective purposes. Again, team skill set and time to learn. And this is something I have seen at multiple engagements so far. My experience is that uh, developers are not comfortable with containers. I mean, every developer wants to learn container because that's hot. People want to know what container is, but learning that is not very, very straight, not very easy. And sometimes it's too much off-centric. And there's an engagement where I had two container specialists working with developers in the Scrum to make sure that developer velocity is not impacted because of figuring out how to solve container problems. While vis-a-vis, serverless is very much closer to what developer has been doing. It's a similar set of codes that they have to write without worrying about underlying infrastructure. And that's where I think this also plays a big role in all that we have learned so far. And at the end of the day, we don't have to boil the ocean. We don't have to twist the whole application or algorithm to fit in serverless. Hybrid is the way. I mean, all the application that I have seen so far, 100% serverless, just few because they are greenfield new start, young applications. But in majority of the enterprise application that we have worked in, it's, no single solution. It's a hybrid that we have seen with lot of going serverless based on the benefits that we talked about and based on the criteria that we just saw. With this, I think, Gigi, let's move to the another case study.
Sure.
Very interesting one on the machine learning.
Right.
Over to you.
Yeah. So I mean, this is a story again related to 7 targets. There are many other places that we use serverless, even in web applications and all. But we thought that talking through this story might make a good value. So that's why we picked one where uh, this is about how within seven, and we talked about 7 targets, right? So how within 7 targets, uh, various models that we have used, how did it evolve over time, right? Evolved over time with the change of technology, with the change of support of various things within the ecosystem. right? When we started 4 years back, or yeah, around 4 years back, there was a lack of data. And just to set a little context there, right? Uh, the important machine learning part within 7 targets is about receiving the email, within the email, identifying the body, identifying the signature, because email contains a lot of things. There's a salutation, there's a signature, and then there's a body. They could be below there, part of a original email to which somebody is responding and all, right. Could be a chain of things. So identifying the body is very critical, so that you can then play with that and play with that content only to be able to identify the intent of the email, right. So with that in mind, um, when we look back 4 years, well, we didn't have data, and and we all know data is what is required for us to have good evolved, good working, good confident models, right. We didn't have data. We started with simplistically using a native service, comprehend a native service for AWS, uh, to get the entities, to get the sentiments, and based on some heuristic formula, try and decide the classifications, right. We were able to run that for some time, but we knew it is not providing us the real value. Um, and over time, when we got data, then we then we went into a path where we wanted to have our own model, right? A data of around 10 to 20K within a year and a half time frame. Uh, we decided to build our own model. We faced challenges, right? Um, right from how do we build it continuously. We wanted to make sure the performance and the cost aspects are controlled, and we don't go overboard with it, right? So at that time, there was no support of serverless within SageMaker. We ended up building custom images for our own Lambda, and those Lambdas or those serverless functions within AWS were able to provide us or infer the or predict the classes for us for the received responses. This ran for some time, maybe a year or so. Um, and the corpus as well increased to like 30 to 40K or more emails for us. And then the support for SageMaker um, supporting serverless came in. There we jumped in and built a pipeline which now is a very controlled mode for us to continuously build and deploy the model and operational. And this has helped us operationalize the whole ML or machine learning part of the story or machine learning part of the solution within 7 targets. Uh, and now we have this. I mean, earlier also we had serverless uh, for inferring, or those lambdas running to get us the right inferences of classes. But now, because being native supported solution, we are able to monitor the the model working or model performance in production, make decisions after some of our users recommend that, hey, these classes are what I want, and these are not working out well for me. So learn from those, build the model in a continuous manner, deploy, get it tested, deploy it in a serverless endpoint. And then the maturity that we got because of this mode has helped us get to a good uh, pipeline to build, deploy, and operationalize the ML world in 7 target. So yeah, I mean, there are more details to it, but I'll pause there and see if and move on to the next one.
Sure. Thank you, Gigi. So while we have been working on these serverless functions and modernization application using serverless, I mean, as usual, we ended up building some reusable component, which is a serverless API generator. And I'm sure this is something that we recommend everyone who is adopting this. This gives us the high speed. So this serverless API generator, which will share the Git URL as a part of the artifact at the end of the webinar with everyone. But and you can reuse it. I mean, this is just a value that we derived while we worked on it, which basically generates your CRUD APIs, and including the test pipelines and then CI/CD pipelines and UTs. So we just have to end up writing business logic. So I mean, this has been helping us with more serverless projects. So this is something that we all can reuse or build as you run on this journey. But that said, Uh, we'll close the discussion today, and let me recap on the key takeaways uh, that we have seen when we did a serverless first approach. I'll not say we skipped the containers completely, though the title of when I say skip the container, but we had a serverless first approach, as many places as possible, as many instances as possible, as many applications as possible. And that has helped us with the reduction in total cost of ownership, both in terms of operational cost. We have seen close to 30 to 35% reduction in the cost, overall cost of operations. Development cost and learning cost, reduced because of the lesser time to learn and easy to adopt the serverless lingo vis-a-vis containers. Very important shift that I have seen, I mean, and I have been a quality guy for quite some time, is on the quality shift left, which, because of the emphasis, and the only better way to test your functions is to write a small unit tests. The code quality has become much better, and developer productivity because less rework at the end of the day, right? And lastly, is that there is no single way. They are not competing. Hybrid is what, in all the experiences that I have so far, we have adopted hybrid mode, while serverless first has been always an approach, but containers are the necessary elements wherever needed. So think from that perspective. Putting everything in serverless may not work out well. So with this, Sanju, thank you for the time. I am done, and we can move to Q&A.
So this is awesome. So there are a couple of important questions that we have faced when we did some of these webinars in house. So I'll just take two questions and then we'll end the session. One of the questions that Chetan has asked, I think you can just Gigi, briefly explain that one. What was the size in a particular case study, and then we'll take that.
Sure. Yeah. Thanks, Chetan, and good to see and hear you. So
Likewise, Gigi.
Hey. So Chetan has asked about the data size. I mean, how did we consider? Is it considered per day, or is it, or how did we consider the data size, right? And I assumed around it in terms of the data size of the data that is getting processed, be it emails, be it responses, be it getting uploaded. So and that's where it depends again, and depends is the right answer everywhere always. But yes, we had to consider per day. We had to even consider per upload. I mean, in the 7 targets world, the users upload the leads via Excel. The users could assign the leads from a CRM. So depending on the number of leads that are coming in, we had to break up the load, and we had to make sure that piece is considered correctly.
So this
perfect. Now perfect. Now it is much more clear. Thank you for clarifying, Gigi. Yeah.
Thanks. Yeah.
So thanks Chetan for that one. So the next question is related to this, that how to manage this workload. We have different pieces of data, and we know that in 15 minutes there is a time period. 15 minutes the functions have to execute. So how do you manage how much to process in these 15 minutes?
Yeah. So that's one important question that has often come up in a lot of our discussions, almost all of the discussions, when we go at serverless first approach, right? And I mean, head on, we all know 15 minutes. We also know that it was less than 15 minutes few years back. Maybe after a few years, it will be more than 15 minutes. But the time limit is always there. What we looked at the workload in terms of size, right? I mean, like Chetan asked, you have to. So let's take an example. In the case of 7 targets, there's a concept of uploading a file, and the file can have 5 records, or file can have 5,000 records, or even more than those, right? And now when they are getting processed, and this is an asynchronous or behind the, in the background processing is happening, and user understands that, then you have to figure out, and then we had to figure out, not we had to figure out, or we had to test what is the right size that can fit in within the time period of the timeout period, and that help us break the workload into batches. We were able to, because we were able to break it into batches while we were processing, and we had to throw in some extra code to do that. But using step functions and using some simple libraries, we were able to easily break up. And because we were able to break up, the processing speed that we were able to achieve, or the time that it was taken to complete the processing of the uploaded file, was much lesser. So yeah, so you could look at this 15 minutes as a constraint or as an advantage as well, in terms of the timeout period, and that's what we did. And yeah, it is not applicable always. Like I said, sometimes you cannot and you don't have to, and that's where you have to then stick with beyond serverless or beyond functions. But yeah,
Okay.
so this is what we did.
So thank you. The second question is about the database related connection. So when we talk about serverless, how do we maintain the connection? When do you restart the connection? So can we just touch upon that one as well?
So this one also came up. This also came up often in our discussions, right? Not just database, but even some of the connections to HTTP connections or some other connections that you're making to some other third parties, right? How do you maintain those connections, and what happens? And do I need to? How do you pool them? Typical design pattern is to have a pool of connections when you are doing a DB connection, so that you don't overboard the DB with a lot of connections, right? So here also what we did at least is, and we have faced some problems when we started. One is, wherever possible, we were using a managed database. We were not going to a SQL database. We were using a managed database, which like Dynamo or something else, right? Which is then not getting into this problem. We are making API calls and we find there. But you cannot always use that. You have to have your own SQL database, and in 7targets we have both. So in a world where we had to go to RDBMS, we were able to control the number of connections by controlling how many requests are processed, and we're queuing it in a queue. That's one. One example that I could cite is reports, right? So when we were exporting or creating exports or reports for users, we knew we were going to connect to a read-only instance in the DB cluster. So we are not going to impact as high to some of the other functions that are happening at the same time, which are going to write to the DB. And we were able to control in terms of how many parallel executions are happening via the queues and that way, right? So we were able to do that. And whenever we had to do it via, so we deliberated on it in terms of putting from the serverless, should I directly connect to the DB to do some writes? We did that for some minor scenarios, but we were always then leaning back to going via a container-based service, which was connecting to the DB, and then that container-based service was again using a database pool manager to manage it that way.
Awesome. Very good. I think maybe we can take one last question because it's past midnight here. So just one more. How do we manage Lambda cold start issues?
Yeah, I think I touched on it, but let me maybe even throw a problem we are facing right now. Few months back, we had to build this service by ourselves for it's called redirection service, right? We all use it when we want to know if somebody is opening a particular link that is going in your email. That's a redirection service. So we in the architecture and design discussions, we thought that, okay, let's go ahead and build it, and let's see if it is worth it, because the speed of development and taking it to production was much fast. We ended up building the redirection service using serverless. And now if somebody hits the cold start, which happens every now and then the time that they take ranges from 4 to 5 to 6 seconds, at least for the first person, which is painful because that person for that long waits and has to wait and may not wait beyond that, right? 3 to 4 seconds is a higher time in the UI world. So yeah, you do face cold starts, and you have to be very careful in terms of and careful in terms of deciding what to do. But we are also started seeing these seeing these technologies which are like, though we are AWS shop, the Cloudflare workers is something that we are looking at or relooking at in terms of moving this service, at least the redirection service, because it is based on a technology of V8 engines, wherein the claim is, and we're still POCing it, so we cannot, but it is in their documented public document. The claim is it takes away the process overhead, and that's why the cold start problem is solved with that. So yeah, so you will have to be careful and pick the right technologies, and I'm hoping, assuming that with time that is getting solved.
Awesome. Awesome, guys. Thanks a lot for attending. And there are a few more questions which we will answer later on one-on-one. Directly, I will send it on LinkedIn. But I really appreciate the time you guys took to join. And we'll be sending you the video for this. We'll upload that. And here are the coordinates of how to contact us. So basically, info at appliedaiconsulting.com, and we'll share that with you. There is also phone number mentioned. So thank you very much once again. It was a pleasure to have you all here. Thank you.
Thanks a lot, guys.